Okay, we know that the energy of a photon is given by this formula hc over lambda. To use this formula correctly, we need to put in the value of energy in joules and the value of the wavelength in meters. So if the energy is given in electron volts and the wavelength is given in nanometers instead, then we just have to convert them into joules and meters. So for example, if it's 2 electron volts, what we have to do is actually to take the value of 2 times 1.60 times 10 to the power of negative 19 times a 1, because that's how we convert 2 electron volts into joules. On the other side, we have the Planck's constant, 6.63 times 10 to the power of negative 34, and we have the speed of light, 3.00 times 10 to the power of 8. So this in joule second and this in meter per second, divided by the wavelength. So we need the wavelength in meters. So if the wavelength is 600 nanometers, we actually need to do a 600 times 10 to the power of negative 9 to convert this into meters. Let's tidy up the equation here. So actually E is equals to 6.63. Let me just copy the numerator out first. And there is a divided by 1.60 times 10 to the power of negative 19 coming from here, and there's a divided by this coming from here. So this whole thing here divided by lambda. So this mass here is the value of K. Alright, that's presented in this question here. This whole mass here is K. Alright, that's all. Ta-ta!